Hey guys, so today we're going to be looking at inverse trig functions for the first time. So by this point you may have already solved an example like this where you got the cosine of 60 degrees equals question mark. And this is really simple because all we have to do is type in cosine of 60 degrees. If you do that in your calculator, type in cosine of 60, it gets you a 0.5 or 1/2, depending on how you need your answer. But in this situation, we have sine of x equals 1/2. And so how do I figure out what the degrees in the angle has to be for that to be 1/2? To give you an idea of what this means, this is like saying I have a triangle. And let's say this is my theta, my point of reference. And I know that sine is the opposite over the hypotenuse, right? We remember that from SOHCAHTOA. Sine is the opposite over the hypotenuse. So if sine of x is 1/2, then that means my opposite is 1 and my hypotenuse is 2 in my triangle. So we need to figure out what is the angle of this theta going to be if the sine of that theta is 1/2. Well, we can do this by using inverse trig functions. And what we're going to do is we're going to use the sine inverse function. So sine inverse is a function that we can plug something into, and we're going to do this, where we put in both sides of our equation into the sine inverse function. So I'm going to take my sine of x and my 1/2, and I'm going to apply inverse sine to them. So let's go ahead and let's do that. So I have the inverse sine of x, and that's equal to the inverse sine of 1/2, right? I get these from the original equation. Now, what happens to the inverse sine and sine? In algebra, anytime we do two operations that are inverses of each other, they cancel out. So sine and sine inverse are inverses of each other, so we're going to cancel out the sine functions, which means I'm left with just x on this side. And then over here, I just have sine inverse of 1/2. And so there are a couple things that you need to make sure you are aware of before you do this. And the first is asking, are you in the right mode? Are you in radian or degree on your calculator? Which one are you in? What I mean by that is this. So here's my TI-84 Plus. If you have a different calculator, you may have a similar method like this, but in my TI-84, if I click on the mode button, you see all these options come up. And right now, it looks like that I'm in the degree function. Sometimes when you click on this, you'll notice that your calculator will have you in the radian function. So just make sure that the radian or the degree option is selected based on what your assignment is wanting. Let's say I want to go to degree. I'm just going to click degree, and then I'm good. All right, so let's assume that this problem is asking for degree. So let's say you've set your calculator into degree. Now what we're going to do is we're going to look at how to calculate the inverse sine of 1/2 with our calculator. All right, and so if I want to do inverse sine of 1/2, what I need to do is I need to go to the sine function, and most calculators in the blue have a inverse sine option right there. So I need to click on the second button and then click on sine, and then you can see it does inverse sine, and now I can do 1 divided by 2, and that will be 30. And since I'm in degrees, my answer is going to be in degrees. So that is saying the inverse sine of 1/2 is 30 degrees. So inverse sine is equal to 30 degrees. And so x is equal to 30 degrees. So that means that if I have a triangle like this, it must be that this angle has to be exactly 30 degrees. Let's look at one more. All right, so let's present the problem here. Here I have me standing here, and I am holding up to my eye what is called a rangefinder. Oftentimes, people use this while hunting, or construction workers might use this to tell how far something is away. And let's say I am interested in how tall my degree of incline is towards this radio tower. So radio towers might have these x's in them. So let's just do that. And so let's say with this rangefinder, you have looked and you have realized that my direct straight line towards this radio tower is exactly square root of 2 kilometers away, which square root of 2 is about 1.41 kilometers away. And then let's say you also look towards the base of the tower, and you notice that the tower is going to be exactly 1 kilometer away. Now, a lot of rangefinders have technology in them to tell you exactly what this angle measure is that you're looking up at. So some of these tools have this technology, but if you have one that doesn't have this technology, there still is a way that you can find out what the angle of incline is. So let's say I want to find this angle measure. What's happening here is I'm recognizing that I have the adjacent and the hypotenuse of this triangle that is made here between the tower and then the hypotenuse and the distance from me to the tower. And let's say I have a problem that's wanting me to use the secant of theta to find out what that theta is. Well, I know that I have the secant. So secant, if you remember, is hypotenuse over adjacent. And so my hypotenuse is the square root of 2 over 1. And so now I need to use the inverse trig functions here. Let's take the inverse secant of both sides and let's see what happens. We have inverse secant on this side and inverse secant on this side. Remember, all I'm doing is writing what is already in these equations inside the inverse secant function on both sides. The reason I want the inverse secant is because now these two secants will cancel out. They're inverses of each other. And so all I'm left with is theta equals, and over here I have secant inverse of square root of 2 over 1. Now, you may recognize that you do not see a secant inverse button on your calculator. This is where it's helpful to understand this, that cosine and secant are kind of inverses of each other. Secant of theta is the hypotenuse over adjacent. Cosine of theta is the adjacent over the hypotenuse, right? So what we want to do is we want to ask, well, how can I use the cosine inverse function to find secant since they're sort of related to each other? They're both dealing with hypotenuse and adjacent. And really what's happening with cosine and secant? Cosine and secant are just simply flipping the adjacent and the hypotenuse in order to find the answer. So if I want to use the cosine inverse here, all I have to do is flip this relationship to find out what theta is. So if I plug into my calculator inverse cosine of 1 over square root of 2, what I get is looks like my answer was 45 degrees. So that may be really important information for you if you're in the construction field or if you're a golfer or something like that. This is how that technology can tell you exactly what degree of incline you are looking at.